Hello and welcome to Technically Speaking, where scientists and engineers come together to chat about a common interest, share knowledge and satisfy some curiosity. I'm Antonia and I'm joined by Jasmin, Soo-Mei and Laura to talk about forever chemicals and whether we should pay more attention to them. So Jasmin, you brought this up to our attention. So what was your interest in forever chemicals?
I've been aware of forever chemicals for a while.
Forever?
Forever. Yes, since forever and ever. They crop up every once in a while in the news. And in 2019, there was a movie called Dark Water about an American environmental attorney who filed a lawsuit against DuPont Chemical, who's a really big chemical company in the US. He filed a lawsuit because they were dumping toxic waste and it was impacting rural communities in West Virginia. So I got really interested from that and also just from reading about it in the news and listening to it in other podcasts.
So Laura, what about you and your knowledge or awareness of forever chemicals?
I suspect I may have seen that film, but fallen asleep during it. But I remember thinking that seems very similar to Erin Brockovich, which I thought was very entertaining. I don't know if that film with Erin Brockovich was about forever chemicals, though. But the thing is, I know very little about them, and as Jasmin said, they pop on news feeds occasionally, and I've never really clicked on any of the articles to find out more, so I'd kind of like to hear from the people that have read about it or work on these things.
Just before I went skiing, this popped up on my news feed about waxing agents that they put on skis being on slopes forever. Yeah, I'd like to also know about the full environmental impact that everything that I do in my day-to-day life causes.
Yeah, and how concerned should you be about them hanging around on those slopes?
Yeah.
How much of a problem is that? Do we know?
I'm hoping Soo-Mei might be able to help us because you've got some experience working with what we call forever chemicals, and we will soon eventually actually explain what constitutes a forever chemical.
I work at Imperial College London as a lab manager right now, but before this role, I was working at a facility doing analysis using this instrument called LCMS QTOF. What it does for you is it can do really high accuracy sample analysis for you. I was doing analysis on the PFAS family for one of our customer. So the customer is trying to tackle this PFAS issue by trying to develop materials that can help remove the PFAS molecules from their samples.
So PFAS, I'm guessing, is a type of forever chemical, or is that the entire family?
PFAS stands for the name for the entire family. There are two molecules in this family which are called PFOA, and also PFAS, and these are the two highest profile molecule from the PFAS family. They have got 8 carbon chain in these molecules. And the longer the chain of this PFAS family molecules, the higher the toxicity it is. I was working a lot with these two molecules, PFOS and P4R, trying to develop analytical methods to detect them in the samples submitted by our customers. It was definitely challenging because we call these molecules as the sticky molecules. Because if we try to inject samples that have a really high concentration of these molecules, they tend to have a carryover effect when we run the next sample of analysis. But it definitely felt like a really useful use of my analytical skill working with this company to tackle this issue.
Okay, so I've done a little bit of analytical chemistry. So you're basically saying they kind of get stuck or held up in the machine that does the analysis.
Yeah.
I guess they tend to bond to it too well. So you normally have a sort of a substrate in there that attracts certain molecules with a certain amount of affinity.
Yeah, that's definitely what it was doing.
But is that what makes it also a useful chemical? Is that why we want it in our products?
Kind of. So, to give some context, so the chemicals that fall in the PFAS family, they were technically first invented in the 1800s, but it wasn't until the 1930s, 1940s before the chemical industry really got interested in them. PFAS as a chemical have some really interesting properties, some that are really good for certain applications. So they're really durable, which also makes it problematic in terms of toxicity. But the things about them that make them really useful and why chemical companies wanted to manufacture them and use them is that basically they're really good at not sticking to stuff.
That's kind of ironic, really.
They get stuck in the icicle machines but don't stick to anything else.
Yeah, they're really good at repelling water. Old, like, waterproof clothing or accessories. They can use PFAS in a coating, soda waxes. When people have heard of PFAS, it's usually in relation to Teflon, because PFAS was used in manufacturing of Teflon, which is also used for non-stick cooking pans.
So I have Teflon cookware, and I also have owned a lot of waterproof clothing over the years because I spend a lot of time outdoors. Part of the reason I'm outdoors is because I do a lot of environmental conservation work. So I'm quite interested in things to do with what Antonia mentioned about the environmental impact and how the coating has changed, because I'm pretty sure clothing is less waterproof now than it was. And Jasmin, you said it was historically used, but now it isn't.
Yeah. Since 2009, perfluorooctone sulfanic acid and its derivatives, or PFOS, their use and uses of other similar persistent organic pollutants have been phased out. What the alternatives are, not entirely sure. It depends on the company. Some are going for more natural derived waxes, while others are looking at less toxic, not banned chemicals.
Chemically, how similar are they? What made PFAS molecules so good? You said it had a long carbon chain. Is that it? Or was there something else that made it special?
Because it has like carbon and fluorine bond in there. This type of bond makes it especially stable. For instance, it has very high thermal stability.
So that's one of the things that makes it more durable, which then means it can't be broken down in nature as easily because nature's not used to dealing with it.
It takes longer time to break down. And also forever chemicals, some people will be wondering, well, forever chemicals because it kind of stays forever. But forever chemical, the F and the C also refers to this carbon and fluorine bond.
So when we say forever, are we talking about in my lifetime, in thousands of years, or in the scale of millions of years?
So I don't really know about this, but I found this paper that says that the longer the chain is in the PFAS molecule, and then it would usually take longer for them to be excreted from the body because of the lower water solubility. And also these molecules that tend to have a higher affinity for protein serums. And all this just adds up, and just increase their elimination time from the plasma.
Okay, so by forever, they just kind of mean longer than other substances we're currently aware of.
Yeah.
Yeah, pretty much. Also, in terms of like how to destroy them, it's a lot more difficult because if they're released into the environment, there's nothing in the environment that can actually break them up or destroy them. You just have to like wait for the chemical to just break down over time.
So there isn't a man-made way to destroy it, though.
Human-made.
Sorry.
Inclusive language.
I meant, okay, an anthropogenic way to destroy it.
Because, as Soo-Mei said, the chemical bond between the carbon and the fluorine bond is super strong. You need to use artificial ways that are usually really energy intensive. There's a lot of research going into how to destroy forever these kind of chemicals because there's lots of concern about the long-term health impacts. You can use chemicals to try to break the bond, so use chemicals like sodium hydroxide or dimethyl sulfoxide. You can also use UV radiation. You can also use electrolysis, so like electrochemical oxidation.
Okay, so some of it could be broken down naturally if UV plays a part.
Yeah.
If you have enough.
Yeah, that's what I was going to say. Is it like a really sunny day? Is it fine as long as it's in sunlight for 12 hours straight?
Oh, no. I mean, some of the companies are already using UV light in the water treatment.
But our main concern is it's going into the environment and it doesn't naturally degrade. Is there a concern about mammals, humans, plant life also absorbing these chemicals?
Oh yeah, for sure. There's like a really big concern of bioaccumulation. So if they get into plants and smaller animals, then it can work its way up the food chain. And through bioaccumulation, animals at the top of the food chain end up with higher dosages
Because I just thought, just find out about the regulation. How are they regulating the acceptable level of PFAS concentration in the drinking water? But what they are doing now with the water treatment is that apparently they would dilute the water down so that they can dilute the concentration of PFAS in the water before sending it to our tap.
Oh, wow. So they need like a secondary source that they know isn't contaminated with it in that case.
Yes. So they call this blending the water. Jasmine, did you have some information about the symptoms that it's going to cause?
Exposure to PFAS can have a lot of different symptoms or result in a lot of different ailments. They're still not entirely sure like what the dosages, what exposure rates you need to have to show that you're suffering from PFAS contamination or exposure. But generally, the main things that would happen to you if you do have high exposure to PFAS are it affects fertility, it impacts your blood pressure, also leads to like delayed growth in children as well as really impacting birth weight, bone variation, behavioral changes in children. It also increases your risk of certain types of cancers, and it can also impact your immune system, so like preventing your immune system to be able to fight off diseases.
So what doesn't it do?
Yeah, I mean, that's why they're still studying it, because it can cause a lot of different things.
And is part of the reason it's so difficult to figure out, one, because biology is really, really complicated and there are lots of other things that can have an interplay with what your body's doing.
Yeah.
But also because there are lots of different types of these forever chemicals or PFAS molecules.
Yeah. 5,000 substances in these molecules.
Wow.
The interesting thing is, with PFAS have been around for decades, but the chemical companies who were manufacturing it, they weren't disclosing that it was toxic to the governments or regulatory bodies because they wanted to use it. Yeah, so that's why it wasn't until the 90s that it was emerging that this stuff is toxic. And at that stage, they'd already been like dumping it to landfill, discharging it into water, having workers being directly exposed to it. One of the reasons why PFAS is a really big concern in some places is just because the extent to how much has been dumped into the environment.
Like in the dark water, yeah.
That is just what I was thinking when Jasmin said them not disclosing information. That sounds exactly like a plot point in a movie. They're writing scripts for us.
Yeah, but it happened in real life.
Yeah. So you mentioned that there were effects seen in children. Is that because of the sorts of practices that were allowed back then, or that the companies could get away with, maybe I should say?
So children being exposed in the womb through their mothers were being exposed through water as well as through other direct ways of being exposed, but also because they were living in places that were already contaminated.
But the main exposure to PFAS is through drinking water.
But so if my water supply does have these chemicals in it or these substances, I don't live near a chemical manufacturing plant, so do I need to be less concerned than some other people?
The thing is, they've found that there's actually PFAS in most of the water in the world.
But they don't know what the dose amount is that would cause an effect, so...
Yeah, that's the other thing. There is PFAS in pretty much all water on the planet. It's just they're still not entirely sure how dangerous very low exposure is.
Yeah.
So you can be less concerned because, I don't know, you're still alive.
Exactly, this is what I'm thinking. I can't really control these things.
The closest thing I thought of when we started talking about this was it's accumulating, kind of like microplastics are accumulating in our bodies. There isn't really a direct way to remove it once ingested because they're small, and what you're going to do, you can't filter that out of a body. So what's the effect? How at risk are we? I suppose this is that hazard, likeliness, risk matrix.
Yeah, just how risky is it? And I mean, it's good that there's a lot of research going into it. It's been recognised as a concern for very valid reasons, but then it's how much of a concern, what could be done in which part of the world.
Yeah, it's difficult to answer. I mean, but I think it's something that people should just be aware of. Not to cause panic, but to pressure governments and industry to do more to get rid of PFAS from drinking water, because there are ways of removing it. You can use certain filters.
And UV light.
Yeah, and UV light, but basically do more because we need clean water.
The water companies in UK, they would carry out water safety planning and tests and make sure that the water is safe for our consumption. And then also by law, your water company has to inform you if there is a problem, with your water supply that could, cause any risk to your health.
Just to go back, if we're asking, water companies to make it a safe level, how much is a safe level then? How easy is that to actually test for?
Especially if it's like all different, what would you say, 5,000 different substances? Or can you just lump them all into one and say, as a whole, they must be below this amount?
I think you just have to work according to the guideline defined by the country that you're in. So for instance, in Canada, the sum of all PFAS concentration in the drinking water has to be less than 30 nanograms per liter. But then in EU standard is like the sum of 20 select PFAS being less than 100 nanogram per liters.
Wow.
So in terms of the detection, it depends on the kind of analytical instrument that you work with. So I'm going to change the concentration into like using part per billion instead. With the LCMS QTOF.
That very specific, well-known instrument.
Yeah, from Agilent. We could detect down to concentration as low as 0.004 part per billion.
Wow.
So that's actually low.
And is that enough to satisfy the regulation in Canada that I think was the strictest one you mentioned?
So we're going to have to convert the part per billion into nanogram per liter.
You're like on that limit, you're in the same ballpark. Magnitude scale?
I guess a lot of attention came to these molecules because of the negative effects that certain communities were seeing. But is it possible that there could be benefits to having these things in your body? I don't know why there would be. This is like mad speculation.
They tend to have really bad impacts. I don't know, unless humans mutate and then they also become non-stick or water repellent.
Yeah.
Don't see much chance of having like a positive benefit from PFAS consumption unless you do mutate and become slow slippery that, I don't know, you just glide through water like a seal.
Is there evidence that they do cause mutations? Because you said they cause cancer, but the mechanisms of cancer are really complicated.
It's an area where they're still researching, so I can't say. All we know is that if you have higher exposure, it's probably just going to give you cancer, if not some other disease.
I suspect that's probably applicable to quite a lot of things. Like,
Yeah.
The list of effects of PFAS on human health is really extensive. So there's like some things that are high certainty, but other things that are lower certainty. It's like thyroid disease, high cholesterol, liver damage, kidney cancer, miscarriage. There was like high certainty, low certainty is basically every other type of cancer and other ailments, including obesity.
so basically, it does all of the wrong things.
Yeah.
Yeah.
It's not good for you. Let's just put it this way.
In a really dark manga that I read called Holic, there was a story where a lady was always sitting in a window and just not moving. And so they went to investigate. This is completely fictional, but they said because she ate so many foods with preservatives, her body was perfectly preserved.
Oh.
Does that mean that she lived forever?
No,
She was
she was
dead.
dead,
Okay.
but her body was completely preserved and it
Oh.
hadn't decayed.
That is very dark
Mm.
Yeah.
indeed.
And it's a good thing that that doesn't really happen. Although I'm now wondering what the effects of eating a lot of preservatives are. And I suspect that's not a straightforward answer either.
No. We'll have to
No.
do some research.
Please don't self-experiment on yourself.
No, leave it to the scientists that are doing controlled experiments.
Yes.
Yeah.
That's right.
Isn't there one of those TV doctors who likes to do self-experimentation by going on weird diets? That's not Michael Mosley.
Sample size is too small.
So to bring the topic of conversation back to the forever
Yeah.
chemicals. Sorry, I feel like I diverted us then. So I'm pretty sure I'll have been exposed to these my entire life. I said I've had non-stick cookware and I drink tap water all the time. So is it possible that it's having subtle effects that I've never really thought about? Because, I've never had cancer. I'm still alive, as we say.
I mean, potentially it's really difficult to tell because, like, the only way of collecting this data or, like, figuring out what the relationship is between, like, low-level exposure to PFAS with health ailments is just basically seeing how people live their lives seeing how people die and just collecting all the data in one of those really giant health studies.
One of those really long-term studies that takes decades.
Yeah.
So maybe a good way of supporting the research is to see if there are any of those out there and signing up to that if you want to do a bit of citizen science.
Yeah.
Yeah, we should look for funding for this.
There's slightly more evidence on like exposure on a large scale. So like if you've been directly exposed to it. But in terms of like the general population who are just consuming what is considered a low and safe amount of PFAS, the health impacts are really uncertain. We just have to see what the science and the medical records show in like 20, 50 years.
Sounds like very sensible advice. I don't think I will be changing anything I do with my life as a result of listening to this conversation.
I suppose here's another thing, is people sometimes when they're concerned about water contamination, they drink bottled water instead of potable water.
The plastic bottles, what is there? PFAS molecules in there as well.
PFAS is literally in pretty much all the water on the planet, so it's even in mineral water.
Yeah, it's in surface water, it's in groundwater, and it's in drinking water. You can detect these molecules in all water samples like this.
And I suppose at this point there is no inverted commas fresh water because it all just goes into the ocean, all gets mixed up together.
I mean, in theory, glaciers and the ice in the Antarctic that's still frozen, they in theory won't contain any, but we also don't want them to melt.
Oh, I am expecting to see a research paper that takes those deep ice cores that says we found some.
Yeah. Yeah, how far back would they have to go before they find it?
Oh yeah, they like find it from like maybe the 1900s, but hopefully not before then. But yeah, it's everywhere.
And it's forever.
Depending on how you define forever.
Forever until we develop sufficient technology to be able to remove it enough from all our water.
Or it's financially viable because there are methods that exist, it's just not widely done.
Yeah, that too. But clean drinking water for everyone, it's a basic human right.
Okay, since we're on to human rights, I think that's a good place to leave it. We've learnt that PFAS, or forever chemicals, are a family of different substances containing this strong carbon-fluorine bond. They have great uses for water repelling, being a highly stable chemical. Unfortunately, that came with drawback, namely we can't destroy it, and now we have it everywhere. Thanks for listening. Hopefully future research will find new ways to understand how we can live better and manage resources more effectively. So if you like this episode, I hope you go through our back catalogue, find some less depressing episodes, and learn more about how we better the world.
I'm not sure it was that depressing. We're essentially saying don't be too worried.
Yeah.
Unless you live near a chemical plant, that you might want to look into their environmental emissions.
Oh,
Yeah.
Yeah, that's a very pragmatic approach to it. Thanks, Laura.
You're welcome. The views expressed in this podcast belong entirely to the person that said them. They do not represent any industry or organisation. If you enjoyed listening to these views, it would really help us out if you could rate us, leave a review and tell a friend. This podcast was sponsored by no one, but if you're interested in funding us to continue to have frank discussions about science and engineering, please get in touch.